Welcome to a presentation on SQL Server 2017 features. The focus of this presentation will be really on development and usage features and like data warehousing and query type abilities. So I won't delve a lot into the database architecture features that DBAs typically look at for two reasons. One, that's usually what people do focus on. So I wanted to take a slightly different focus. The other is, and I will mention things, so I won't skip over that, but the other one is that there's so much to cover that to get into the DBA alone, I could be talking about always on for an entire hour easily. Probably an entire day of training could go on that, and there's all kinds of clustering methods and ways to get disaster recovery and all kinds of replication and things. So I'm not going to talk too much about that. I may do a follow-up later on about that, and I'll probably borrow information from my DBA friends out there. But I've been doing SQL development side for so long that I'm really eager to do this topic and just talk about the many rich features that are in SQL Server. It's really staggering, and I think when you see how much is available in SQL Server, you're going to agree it's pretty amazing how much is in there. It's I think, and part of the reason is it's been around a long time, and so new things keep getting added. And the recent releases have just been adding major new things, not just little fixes and things like that. These slides are available on GitHub, as all my content is, github.com/bkafaki/shared. And I am a data solutions enabler at Microsoft. And there is a link at the bottom here, which is where you can get a sort of side-by-side comparison. SQL Server has different editions. There's the Enterprise Edition is the one I'm really going to be focusing on, because that offers all features with full capabilities, no limitations. There's Standard Edition, which offers most of the features, but then you have to kind of sift through, and that link there will let you do that, will tell you which features are fully supported and which ones may be somewhat limited. And then there's Express Edition and the Developer Edition. So you can download and use the Developer Edition, and it's free of charge, and it's the full Enterprise Edition features. It's not meant to be used. It's not to be used for production use and things. It's meant to be a learning tool and that kind of thing. So that's really the goal, but it's great if you, for people like me, want to do presentations, I can use it. All right. So my first slide, which is kind of a typical one for Microsoft, but worth pointing out if you're not familiar with SQL Server in particular, 2017, SQL Server went to Linux, which is something I have to say I didn't ever expect to happen, and it did. So I'm very excited about that, because I've worked in Linux shops and consulting, and it's kind of frustrating because I'd have to say, yeah, you can't use SQL Server on Linux, so if you want to use it, you have to go with Postgres or MySQL, but that's not the case anymore. Now you can use all the features and robustness of SQL Server on Linux. There are some features which are not there yet on Linux, admittedly. I'm not going to focus on that, so I'll also qualify this that I'm really focusing on features that are available, all features supported on the Windows version at this point, but most features are also available on Linux. SQL Server is an industry-leading database in the performance area. Every release gets better and better, and it's just getting smarter and smarter about how queries run and the query plans used. It's really amazing. I'll talk about some of that in 2017. And it's an extremely secure database. I honestly feel that SQL Server is, and I could be wrong because I don't know everything about every other database, but with all the features for security in SQL Server, I think it's the most secure database out there. And I say that because it's just got so many rich features. And when you use it in an integrated manner with other features in Windows, etc., if you're using Windows, and in Azure, if you're using that, the integration points and the way it can be really put together in a very tight, secure manner is why I think that. And you'll see, I'll talk a little bit about some of these things, and you can make your own mind up. But one of the things I really like is a feature called Always Encrypted, because it really protects your database and protects credentials so that people can't hack passwords, etc. It's the only commercial database, according to my slide at least, that has a scalable, integrated machine learning server built into it. So you can scale R and Python. Python was added in 2017, and I'm really excited about that because Python is just a cool language and it's great for machine learning. And it supports reporting in two methods, and I'll show you. It supports operational reporting and analytical reporting, and you get that out of the box. So let's get in. Now, the best way I think to approach SQL Server is to talk about it as a server-based architecture or service-based architecture. What I mean by that is you can literally go into Windows if you're running it there, or Linux, and you can see the different services that are running. And those services kind of group different types of functionality within SQL Server. This is the only database I know that does that. I've worked with DB2, I've worked with Oracle, I've worked with Postgres, a little bit with MySQL, but I haven't seen this sort of service-based architecture. It kind of emerged in 2005 when some of these services started, and it's kind of grown, and I really like it because you can move the services around if you want to run them on different servers, for instance, in most cases. You can not use some if you don't, so you can just turn it off and you're not going to be incurring the overhead of a service. So let me talk about that a little bit. In the upper left-hand corner, you have database services, and that's where most databases would stop. Those are your core database features that DBAs talk about a lot. Your disaster recovery is there, your security is there, your t-sql language I'm going to put there. It spans really different areas to an extent, but I'm going to put it falls into the database services. And when you connect to SQL Server, if you use SQL Server Management Studio, it'll actually say what service do you want to connect to in some cases, so you can actually connect to them differently. However, you can interface with them in SSMS even if you didn't come in that way. You can still get to like the Integration Services Catalog and things like that. So it's really great. So the database services includes things like encryption, high availability, and I'll talk a little about those features, quite a bit actually, but also integration services. So many databases do not provide you with a way to move and transform data, what we call extract, transform, load. And yes, those letters keep getting shifted around by people, but in the end, it's moving data and doing transformations on the data. As you do so, most databases don't give you something to really do that, and certainly not well. Some may sell you a third-party product or their own product, but with SQL Server, it's out of the box, you get it. And it's integrated with the database. It's a first-class extract, transform, load, ETL product. It can work with data on many different databases, many different platforms. It can pull from big data solutions like Spark and Hadoop. It's got rich data sources, and there's even third-party tools to extend that if people want to do that, to connect with things like Salesforce. So it's really cool. It connects. I've never had any problems using it. I've had cases where I wanted to just say, let's just buy SQL Server just so we can have integration services because it's worth it for that. It provides powerful developer tools. So integration services, you get SQL Server Visual Studio, you get Visual Studio, which extends itself to support creating programs called packages and integration services. And again, there's a catalog that's integrated with the database, which is really nice because you can actually go and query the ETL engine. And I'm going to do a presentation. I just did one with my user group last week, which was on SSIS and how it works. And it's a very robust thing. It has lots of great features. And the catalog is integrated, which is nice because you can actually go in and query the catalog and say, when did packages run? How long did they take? Did they fail? Etc. And it integrates with the job scheduling system, SQL Server Agent or SQL Agent. And so you've got everything there. So that's great. I'm going to move kind of the right side because my favorite box is in the middle, so I'll come back to that. On the upper right-hand side, you also get a very extensive support for reporting. Now that's another thing that's unusual to get in a database product, reporting out of the box. But you get two very powerful reporting tools. One that is really more of developer reporting, where you get turnkey sort of packaged reports that you make available to the business, and they tend to be more tabular reporting, operational type of things, and that's called SQL Server Reporting Services. The other one you get is an analytics-based reporting, which is called Power BI. And again, Power BI availability is only if you have Enterprise Edition, so I do know that distinction. But you get analytics reporting, so you get that Tableau functionality type thing. If you can click view, Tableau, that kind of thing. Very visual, and I'll talk more about that. Nice feature on both SSRS and the Power BI is you can control how it renders and get really nice rendering in mobile apps, whether you're using a tablet or you're using a browser, etc. It can render nicely even on phones. So that's something Microsoft did a lot of work in the last couple of releases to make it really great, and it's outstanding now. It used to be a problem years back, but it's amazing now how good it is. Analysis services is another one of my favorite things. It's one of the things I've really focused a lot on just prior to getting into machine learning, because it's sort of a precursor to where machine learning came in. It provides what's called a semantic layer to get to your data, and I'll talk more about that, but the idea behind it is it's really targeted at those analytics, those visualization tools that need lots of slicing and dicing of data, and that what it allows you to do is create sort of models, they call them, analytical models that can then be used, and you point your tools at those. And a nice reason for doing that is a couple, the most important one being performance. It will make that click happen fast, and you can get to your data because people do not like to wait. But the other part of it is you can have a single source of truth with it. And I'm big on that because as a business intelligence person, one of the things you always get over time is people question the data. I'm getting a number that doesn't match. Sue has this number. I have this number. Why does sales not match? Why is this not matching my spreadsheet? And it's because people maintain data and they tweak it and they do things. But if you have the right data from the right source systems and you've cleaned it up and you've done your ETL properly, you have a single source of truth. Sometimes with self-service tools like Power BI and Tableau, etc., people, if they're doing it themselves, they could be pulling in spreadsheets. They could be pulling in, Harry gave me this. I typed it in from a napkin or whatever, and they think it's right. But if you use the tabular model analysis services, you can sort of point them and say, this is the source of truth. We've prepared it for you. It's very easy to prepare the tabular models, the most recent one, so you can give it to your users, and then you know that this is right. Whether they query it right and do things like that, that's up to them, but at least you've given them the correct source of data. Okay, finally, the middle box, which we'll talk a little more about. Machine learning is the revolution going on right now. Now, it's a very broad category, so you probably hear artificial intelligence, machine learning, deep learning, data mining, all these different terms, and they all I'll just categorize them all under sort of machine learning. I think that's the broadest categorization. To some degree, analytics, sometimes like big analytics, we'll say, also is often categorized as machine learning, so it fits in there. Oftentimes, when you use tools like Python or R, you run into scalability issues right away, and that's because both Python and R are designed to be client-based tools. By default, open source code that you're using does not recognize that you may have many CPUs, lots of memory, etc., and it won't necessarily parallelize its processes, and you can run into a lot of issues like that. So you might do something, for instance, I've seen this with R. You try to pull in a data set, and it creates an in-memory thing called a data frame, and once you fill up memory, it just stops. Doesn't page, doesn't try to do anything advanced, it just stops, and you're done. Get more memory, reduce the data size. Those are your options. You also run into problems real quickly where you're just trying to run a complex model, and machine learning can get very resource intensive very quickly, and you'll end up taking a long time to run something. So machine learning server scales that. It has commercial functions, and I have a slide in here that talks a little about that, but it has special commercial functions that replace the standard open source ones. Many of them are actually much better and much more powerful than the interfaces you get with the open source functions, but the best part of them is they will do things like, it's called chunking, so it'll page data in and out of memory if needed. It can compress data quickly. It can do parallel processing and make use of all your memory and do all kinds of great things. So the machine learning server can scale really to the level that SQL Server can scale. It does not scale out, which is what a big data tool would do like Spark or Hadoop, but it will scale within the server just like SQL Server or any server process like Oracle would do the same thing, scale within a server level. So it's really important, and it takes advantage of all the things you know and love about SQL Server, which means since it can run all within the database, you can actually write stored procedures in R and Python. That means you can secure those stored procedures, you can secure the data they use, you're not extracting data, which would be the alternative approach. You have to pull data out of the database and potentially expose it to security risks. Somebody's downloading and extracting data, maybe putting it on a file share, maybe putting it on their laptop. Not a good idea. So now you can control and contain it in the database. You can run it from SQL agent jobs. You have a job scheduler. So you can really operationalize and control everything right within SQL Server, and that's really powerful. It's a great story. It's a great place to do machine learning. It may serve all your needs. Now, being SQL Server, it's not designed necessarily to work as extensively with unstructured data. So the best use case for it is you've got lots of data in your SQL Server database. It's the perfect solution to do machine learning with that data. So there you go. Let me move forward here. So my favorite thing about SQL Server, actually, and it sounds like a strange thing to say, but it's actually SQL Server Management Studio. It's just an awesome IDE. It lets you do anything, and I've used it for years, and I'm still learning new features. And then I'll watch a demo, and somebody right mouse clicks, because that's the thing in Windows to discover new features. Right mouse click, try it, and I'm amazed. New features. Wow, I can script from there. I can do this from here. I can create a new table here. So it's really great, and I just like this screen because I started. It was painful to just do explain query plan. I used DB2, and you had to write it to a table back then, and then look at the bits that it wrote out and figure out what it was telling you. You get a visual interface, almost everything, and I mean that's what Microsoft does, right? Lots of visual interface things, and they do a great job with it. So here you're getting an example of doing a query plan explanation, and you can see that some of the new features you can even see is it has a feature called Query Store. It stores the different plans that it's used over time, and so you can do things and see what's happening. So this shows like the top 25 resource consumers. This is a DBA feature, obviously, so DBA is tuned into that because it's really a powerful feature. I'm going to talk a little more about some of those, but also just look at the visualization. You can see here, how is my query running? You can see nested loops and key lookups and everything. So you get a very good picture in SQL Server easily as to how queries will perform and what they're going to do. So let me walk through features a little bit more detail. So key features I want to talk about again. I've talked a little about SSAS, but I want to really highlight that because sometimes I've gone into work, and if you don't have that, you're going to be looking for some sort of third-party tool. If you're in the open source world, maybe you look at, I looked at one called Pentaho. I think that went commercial. There's a lot of different potential tools out there. There's one, Apache has one. So there are ones out there, but then you have to bring in, it's a separate product. It's not really designed to integrate. So it's nice just to have it there, and it's very performant. SSAS is designed to really perform well. It's optimized, and it does parallel processing out of the box. You can actually write multiple threads. It will parallel process. It uses a catalog. It's all integrated. Really awesome configuration capabilities. 2012 was a turning point for this. So the configuration options now in SSAS is just awesome. That was the release I really loved, 2012, because they added environments and configurations and project parameters and deployments to the database. It's just really good. All right, that's my soapbox. Reporting services also really great, and Power BI we talked about. The analytics, we'll talk more about that. t-sql is extensive. In particular, what t-sql has is windowing functions in more recent years, which is really great because it used to be painful. You're trying to do subgroupings and groupings, and you may be listing stuff, and you say, but gee, I'm summarizing this way, but I'd really like to summarize in a different way within the data, and that's windowing functions. It's basically adding to t-sql some sort of analytics capability. So take a look at those. You get a lot of questions on those in interviews, so I'm always trying to remember all of them because I don't use them all the time. A professional job scheduling tool built into the database and accessible from SSMS is called SQL Server Agent or SQL Agent, and it's really great. It integrates so you can set up job steps, you can send emails. So I like to say, send an email out saying I've started an ETL load. You can have any number of steps. You can have notifications if it fails. It can even send something to your phone. Still has pager stuff in there, but it can notify you that there was a problem. You can tell it what you want to do if it fails, like continue on or don't, etc. It's very rich. It can run t-sql directly, or it can call store procedures, run SSIS. It knows. So if you say I want to run SSIS, it exposes configuration parameters and how to run SSIS and where do you want to point to, because you can run SSIS, as I mentioned, on a different server, and you can point to that server and use that SSIS. So very cool. Good job schedule. I really like it. Cannot be overemphasized in many ways because DBAs in particular, I'll say, you got to run stats, right? I was watching a presentation and someone said, well, you got to manually run stats. And I'm like, why would you manually run anything in SQL Server? Use the SQL agent. It's a job scheduler. Run your stats, run your backups, run anything you need to run on a regular basis. You can put it into job scheduler. You can have multiple schedules. You can do all kinds of great stuff. Client tools, I showed you SQL Server Management Studio, but there's also data tools. So there's a whole visual designer in SSAS where you can drag and drop. So you just drag and drop a source control, and what you typically do is there's two parts of it. So you have your control flow, and then you create a data flow object, and then you can go inside that, and it's a visual thing saying, here's my source, here's my transformations, all this stuff. And it's so powerful. You can even, if you say, I can't quite do something, and frankly, you don't run into this much, but sometimes you want some weird format, you really need to control the data. I've had problems when I pulled in like CSV files because I'm getting from external customers, and sometimes they just don't include certain columns. You get whatever you get, and you're like, this is money coming in, we need to record it. So what I would do sometimes is you can write C# or VB.NET scripts and integrate them into your ETL process. And so it's great. You can even parse through every line. You can have it called and parse it through a script. So you can write your own stuff. You can write anything. You can even write source and destinations if you like. That's a little more work. It's a little more outside of SSIS itself. But I've never had to really get into that. But I have used scripts to do specific processing. Really good example of script I wrote once, just to show you how extensive it can get. I had a requirement to back up SQL Server databases, multiple SQL Server databases, to Microsoft Access databases. And that's not something anyone's ever asked. Usually people say, I want to go from Access to SQL Server. But in this case, they wanted to be able to do backups, and I think it was for being able to audit and get copies of the data they could look at offline. And I was able to do that using a script task, a C# script task right within SSIS. So I was able to do all that. So it's great. You also have Visual Studio, all kinds of extensions and things to support SQL Server. One in particular DBAs like a lot is they can do database projects, so it actually supports deployments and monitoring of what changes are going into a database. You can download and use the developer edition of SQL Server, so you get enterprise level features that you can learn and test and develop on, so it's great. You also, Excel and Power BI work really well with it, so you can also use those tools. And as I mentioned, you have machine learning support built in. Features I haven't mentioned yet is in-memory tables. So how many times do you have an application, especially like a web application, it's getting slammed a lot. It's a lot of activity going on, and it's really hard to keep reading and writing to disk for everything. Well, one option you have now is to use in-memory tables, and it can use something called even column store, which is it pivots the data. It's actually, instead of storing all the rows of data, it stores one column separately from other columns, because you're not always using all columns, and then it can compress it into memory super fast, really good. You also have, and that's, so the column store itself is also a separate feature, but it works well with memory, but it's again that column store. So column store is really ideal for data warehousing, reporting, and stuff like that. Slicing and dicing is really what it's optimized for, but it can also come in handy in OLTP situations. Now in SQL Server, you also have stored procedures and Scala functions and table value functions and other ones in there, but those are the main ones I've used. So stored procedures are pretty much, you can run whatever you want. They can take input and output parameters, so they can act very much like functions. They're the workhorse of SQL Server for developers. You can do a lot with them. Typically applications will call stored procedures to do the reading and writing and things to the database, because it will be much more optimized. Stored procedures will use plans, so they will, that usually will store plans for them and how to get to data, etc. So they're really optimal. Scala functions are something where maybe you have something you want to run on every column. You want to maybe do something with a date or a value, and there's no other way to do it, and you want to run it in this column. So you can create a Scala function, and then in your SQL statement you can just include that call, just like any native function, and it will use that Scala function and do the work. And table value functions, which DBAs tend to not like, but I got news for DBAs and newer features, new releases, 2017, it's even getting good at handling table value functions with lots of code. But what table value functions are, if you haven't used them, is imagine you have a situation where you have very complex query logic, and it may have to act differently depending on what you need. For instance, maybe you want a different level of aggregation, or maybe you want to be able to filter it differently, but you need to use pre-filtering here, like a common table expression, and then take that pre-filtered data and then do something. So you have complex queries. And so think of a view where you said, I wish I could pass a parameter to the view and do something. That's where table value functions can be very powerful. So you can write code that will do things, anything you want really, like a store procedure, but then at the end you say, now return this as a table. And because it's returning as a table, you can call that function like in a from statement, pass your parameters in parentheses, but you can order by, you can group by, etc., as if it was just any other table. Now warning, because every DB out there is probably saying, don't use these. Be careful with the volume, how big it is. I wouldn't do these with millions of rows. I've used these in anything in SQL Server, or any programming really. You should use discretion. And definitely here I would say use discretion. It's not to be used everywhere. It's not something I would want many developers doing, because sometimes developers get one thing and then they go crazy with it. But it is useful. If you have a relatively small set of data, especially, probably not a very good use case for transactional processing because of the overhead, but in a reporting system, when you know what you're doing and you can accept the performance and you've confirmed that, can be very powerful. I've used it in particular for when I'm doing like accounting reconciliation within the data, and there's just all these tweaking, and I've got to do pull out points that have already been reconciled, etc. It worked out well. Link servers. Link servers allow us to connect to remote databases, not just SQL Server, but I could connect to MySQL. I've done that. Postgres, Oracle, whatever, and you can connect to it and then query them as if they were local. So it's a really powerful feature. Watch the security on it, but it's a powerful feature. Active Directory integration is great too. So one of the things I like with SQL Server too, if you're in a Windows environment, is I can go in and with Windows authentication, as long as I'm authorized to use the database and Windows authentication is turned on for this database, I can just go in and I don't have to log in. I don't have to give it credentials per se. It'll let me directly access the database, but it knows who I am, so it's authenticated and very secure. In fact, probably more secure in a way because I had to get into Windows in the first place, and that's great. And that can also be used with connection strings as well. So if I want to do something from, say, I'm querying something from another tool, it can actually use Windows authentication instead of prompting me, or worse, storing my ID and password somewhere. So that's one of the risk points. But if it's Windows authentication, I might be using a tool like Excel or something, and it knows who I am, and it's not going to prompt me for passwords, which means I don't have to store passwords anywhere if I've got it like as a batch job. So that's my soapbox there. Master data management and data quality services are two cool things that you get. I think it was 2014 or 12, I think actually, at 12 it was added those. Master data management is a big thing now because you've got certain types of data that you want to be clean and standardized, and maybe it's not really transactional data. Hospitals you have providers, you have what hospitals are in your network, ICD codes, big thing, it's clinical codes. So you got all that. It's really ideal for coded data, but it can be any kind of data that you want to you really have to keep it clean. You have to keep it centralized. You want to share it among probably multiple data marts or applications, and that's where MDM comes into play. And out of the box, you get an MDM implementation, Master Data Services, as part of SQL Server, and then related to that, something called Data Quality Services, which is really cool because it'll actually generate a website GUI and everything for both of these. But the DQS is cool because you can actually set up all kinds of rules. So you can give the business rules and say, whatever rules you want, the range of values should only be between this and this. It can only be this type of value, no nulls, etc. And you can put that into DQS, and then when you're doing ETL work, it integrates, and it will kick things out that don't follow the rules, and you can push it back, and somebody can fix it, or you can decide what you want to do, but you have control over the processing. And data compression is built into SQL Server. I think it's underutilized because I haven't seen many places use it, but it's a great idea because not only do you save space, but it often performs better than not using it, because the compression, then you get more data into memory. It can pull up faster because it doesn't have to. It can pull it into memory faster because it's got less to deal with. So data compression is a really nice feature, and it's really easy to use. So kind of highlighting again, Power BI report server. So I want to talk about what the difference is, like why reporting services versus Power BI. So reporting services is your traditional reporting. It's more textual as a rule. There can be some visuals in it, but it's generally more textual. And you can have business users subscribe to it, so they can subscribe to reports. I want that report, and it will get delivered to them through email if you want, and stuff like that. You can do all those things. Whereas Power BI, and typically SSRS reports are typically written by some sort of a developer, a SQL developer or something, because much as early on it was attempted to give them users a sort of interface to it called Power Report Builder, never quite caught on. Users never quite got their heads around how to use the reporting tool that way, so it tends to be something that a developer would write the reports. It is powerful and it is easy to use to a developer. If you have the concepts in mind, it's not bad. But Power BI is really meant to be that end-user self-service BI solution. And this kind of gives you an idea what the difference is. On the left, you can see a typical SSRS report. It includes some visuals to give you an idea. Yes, you can do them, but it's not meant to be interactive. You notice there's some parameters that user can set up. So you can set date drop-downs. You can even have code in the database, the store procedure that will return a list of values. For instance, if you wanted to maybe pull a list of company codes out, you can do things like that and have drop-downs. So it's got really nice features that way. And you can see even a button there, View Report. And there's options to download a copy of the data and stuff. So security, I know, is an issue there, but you can do all these things. So it's a really good report writer, bottom line. On the right-hand side, though, the hot thing now is analytics. I'm sure you hear it everywhere, analytics, and that's what Power BI is designed to do. It's done extremely well. Working at Microsoft now, it's a very hot product. It's doing extremely well, and I can see why. It's very extensive. It's got lots of features. But the coolest thing I like about Power BI is the fact that even I can use it, and I'm not really a typical visualization GUI kind of guy. I'm more like somebody who likes to work with the data on the other end, and I like writing machine learning models, but the visualization aspect, I kind of stop usually. But I can even use it because it is pretty intelligent. So when you put things together, if you were to go on this visualization and click on a country, for instance, all the data related to that will filter for that country. And then you might click on one of the bar chart items, maybe it's a product, and it will filter for the product. So the integration and kind of links between things is automatic in Power BI, and it can read from just about anything. So I've not come across something I said I can't get at it. And if you do find something you can't natively read with a connector, you can integrate an R script as a load, a data source, and the R script could then, whatever R could read, you could then render to Power BI. And there are some limits of where R scripts can run, etc. But if you're using the free version desktop, which is I think what I use, that does support R, and anything kind of local desktop development supports the R scripts. Deploying might be another issue, so watch that. You'll have to check your version of Power BI service if you're using the service. Power BI desktop is free. It's powerful, and I recommend people use it the way they would use Excel. When you get into wanting to share and deploy on the cloud, that's when you get into having to pay. SQL Server, though, Enterprise Edition, will give you a server so you can share your Power BI reports on premise. So that's why I included here as a great feature. And again, I mentioned you can render reports really nicely, both SSRS and Power BI on mobile devices. Optimized query processing is another feature. There's a lot of features here, but optimized query processing is really cool because what happens is in the legacy world or previously used to be that SQL Server tries to say, okay, I'm looking at stats, I'm looking at this, I think I'll need this much memory to do the query, and then it gets into it and starts realizing, oh wow, I don't have enough memory, so it starts paging to disk and starts thrashing around and all that kind of stuff. Adaptive query processing is a feature where now it says, oh, I'm getting more rows than I expected. I'm going to give myself more memory. Let me ask for more memory and go on, and it will do that, and it will therefore eliminate or reduce at least. This says all the memory. It's going to try to eliminate that thrashing and that paging. So it should perform a lot better, and it's dynamic. And that's kind of a key thing that I'm seeing with the performance improvements SQL Server is adding. It's more and more dynamic and intelligent in how it operates. And this is another example where SQL Server automatically will tune queries and plans without you even having to tell it. So it will look at it, it'll monitor it. It has a thing called query store, so it's storing a history of plans that it's used in the database to get to the data, and it can even autocorrect. So it can go back and use previous plans, and you can have it do things like add an index to a column to improve performance, I believe. And then if it finds it's not working well, it can roll back to another plan. So it'll actually watch it and say, oh, that's not good. Let me roll back to the earlier plan because it's not performing so well. Analysis services. It's time to talk a little more about this. The bottom line is this. When you want to do slicing and dicing with these analytics, you're looking at total sales by country, and then someone clicks on a country and you want to see a product breakdown, and then you click on the product and then you see it by regional office. If you did that with typical SQL, and that's what it was done and is still done in many cases to do these things, you're going to have a problem because you just said summarize by country. Imagine you have 1 billion rows in the table and you say summarize by country. So you're going to wait a while, right, until it summarizes, select some amount by country. And then you say, oh, I want to see that now by country, but I also want to see it by regional office. By country, so you got to wait for the query to run again. And then so you're going back to the database and sending queries. It's not going to perform well. And this isn't a visual environment where you want instant responses because you're clicking on things. So the OLTP data is instead fed into, and it can be other types of data as well, but it's fed into a process in which the data is, there's two ways to do this. So one way to do it is create a cube. And let me see if I can show that. I think I have it here. Oh, don't have it here, bummer. I have another slide somewhere, but I've lost it here. But what you can do is use a cube, and that was the first implementation to solve that problem. What a cube did was it would just basically pre-aggregate every combination of your metric, such as sales amount, and then it would pre-aggregate that. Here's sales amount by office, here's sales amount by country, and it would store all those different versions of summary. So all these different summary levels, aggregations, would be done ahead of time. That way, when you said, I want sales by country, it says, oh yeah, I did that last night, here it is. I just did that. I already prepared that. And you said, oh, now I want country by office. Okay, pulls it right out. So it's really like just pulling it out of an array. It's pulling out of a grid, right? That's why it's called a multi-dimensional model. And they call it cubes, but cubes implies 3 dimensions, but it's really any number of dimensions, so it's really n-dimensional. And the MDX language, people always get confused by it because they want to think like SQL, but it's not like SQL. The MDX language is actually meant to pick things out of this multi-dimensional grid and say, oh yeah, this intersection with this, think like 2-dimensional. If you ever play Battleship, you go here, here, pull that number out. That's what the cubes do. The cubes are great. They're falling behind in popularity to the tabular model, which is newer. The tabular model does everything in memory. So with the tabular model, instead of trying to pre-aggregate everything and then store it, instead, and there's different levels to which it might not store everything in those cubes. There's roll-up and mole-up and things like that. So sometimes it will do a little bit of rolling, of pre-aggregation. Sometimes everything, you have control over that in the cubes. With the tabular model, you identify what data you want, and you essentially suck it into the memory of the computer, and it's compressed, and you can work slice and dice right in memory. And because it's in memory, you actually bring in the granular data, the low-level details, but let it slice and dice and aggregate on the fly. It's highly compressed and it's fast. So that's what happens with Power BI. Actually, Power BI does that locally, even on your own machine. It uses that same process. It compresses everything's in memory and slice and dice. But you can also use cubes with it. So the tabular model is really popular because it's easier to create the models because you don't have to go through this sort of complex process of mapping out all those pre-aggregations. Instead, you're really just kind of creating an in-memory table and then slicing and dicing. And so that's really what's going on. Analysis services allows you to have it as a separate process, and you can create these models. And another great reason for doing it is a single source of truth. You want to make sure that if the business gets the right answer, so that you don't want the business to bring in different types of information and then wonder why it's not agreeing with what a report's telling them. You want it to be consistent. And as a BI person, you want to be able to tell them, yeah, this is the right answer. I know Mary's spreadsheet or Joe's spreadsheet says something else, but I don't know where they got that data. Maybe they just heard it from somebody. But this is from our source systems. This is right. And so being able to create these models ahead of time and then tell your business to go to those gives you the control of getting it right, but the flexibility of having self-service BI. So you can kind of get the best of both worlds with that. We also have new features called Temporal Data. So if you've used warehouses, this is where I tend to particularly think you see in the lower corner here, slowly changing dimensions. So a quick example of how you would use temporal data that I think was slowly changing dimensions is if you had somebody who was in one office, say Boston, say a salesperson, and then they move to the New York office. So you want to make sure that if you were doing historical, reporting, you want to say, okay, well, until they move, say it's June, so from the beginning of the year to June, you want to record them in their first office, and then for the rest of the year, you want to record their sales as going in the other office. And the problem is if you were to just update it so that they were in Boston and now you just change it so that it's New York, then everything they did, even when they weren't with whichever office it was, with New York, would suddenly end up in the wrong office. So slowly changing dimensions can cause a lot of issues if you don't track them. The optimal way usually is to say keep all historical changes so that as things move around, if a person, a customer moved from one state to another, or different things, or offices shifted, maybe you move it from one region to another, you want it to follow and the reporting to reflect what's really going on in the business. And that's slowly changing dimensions. It's also things with just auditing data and different reasons why you need to keep track of things changing over time. And now there are special SQL enhancements to support temporal reporting that there's differences in the data. So if you look at this, you can kind of see the idea is you can look at things over a period of time, and you can see there's t-sql extensions to support that. So I'm not going to get into that, but if you're interested in that, I'd say take a look. Security is also really important, and it's a big part of t-sql, and Microsoft takes a very multifaceted, you've got to look at it from many angles. It's not just a matter of saying let's encrypt the data. It's not just a matter of saying who can get into the database and do things. You need to do it at many levels to properly protect your data. And so you can see here, encryption is part of it. There's encryption at rest, but what happens when it's in transit? How are you protecting it? So you have encryption in transit. You can also have situations, so you want to say, let's just always encrypt it. So there's actually that option also, always encrypt it. but you also have to control access to the database, restrict applications access to the database to just what they need, and monitor. Auditing is a key part of that too. Ideally, you don't want to have people get into your data that shouldn't be there, or potentially hostage data situations, etc. You got to be very careful of that. Auditing isn't so great if you find out after the fact, but it's good because you may find patterns of problems that are coming in. Maybe people a lot of times when people do hack data, they're actually playing around earlier, and if you can find those things, you can stop it before it happens as well. So auditing is key. It's also a good way to kind of do forensics afterwards and just kind of monitoring things. By the way, there's really awesome features now in Azure for doing a lot of that. Auditing is really getting amazingly powerful, and there's even artificial intelligence to do threat detection and things, which is great. And SQL Server has some of that too, so it's something to look at. So graph APIs have become very popular. There's graph databases, like Giraffe and Apache. You've got Cosmos DB has really great graph database support, so if you need large big data type scale for graph database, Cosmos DB is a good way to go. But you have graph database extensions now, graph model extensions to t-sql to help you model things. And graph databases or graph concepts are simply, you have something that's sort of in a networking kind of way you want to represent in data, and it's not so good to do with relational data. It doesn't get well supported by traditional relational methods. Example might be social networks are good examples. So you've got someone who's connected on Facebook. Mary connects to John and Harry connects to Mary Sue and Mike, and that whole thing. And you can picture like a node would be, starting with Mary and then going to John and then going to other people, and you can see this sort of branching out, which is like a network, social network, right? And physical networks could also fit like that. Geographical things can sometimes feed that if you're trying to say, how do I get from one point to another? And a lot of times the idea behind those is also, what's the shortest path between things, and how many different things connect to things, etc. So this slide shows you some of that, and I'd say just take a look at it, but you can get some good things in here. Kind of this slide probably in a bad place at this point, I realize, but you can use SSAS for a lot of different types of tools. Getting back to my graph database, that one slide, sorry, was a little bit out of place, but this is a great example with graph database representation. You can see this t-sql extension specifically to support the nodes and then the lines between the nodes, which are called your edges. So take a look at that. It's pretty cool stuff. And again, another examples of this stuff, how to query it and etc. using the extensions. And graph tables are not only available in t-sql or SQL Server, but you can also get to them through SSMS, which is another thing about SSMS. It really provides a single point where you can navigate like a file system to pretty much everything. So I'm not going to get too much into this because there's a lot to talk about, but take a look at those slides, and I think you'll find a really great functionality. Another area that's very popular now is it's geographic kind of stuff and geometry, spatial things. And spatial support is now built into SQL Server. There's extra extensions to t-sql to support that as well. And I'm going to again point you to this because I realize there's a lot of stuff to cover here, but go take a look at it. There's some really neat stuff. I think I may have a sample. Yeah, here's a sample of just how you can use t-sql. And what I find kind of cool here too is how SQL Server SSMS will actually render it in a graphical way. And you can do that also with tabular and things, slice and dice also within SSMS as a way to test things. So it's great that way. And I talked a little bit about R and Python, and I want to just talk a little more about it and move on. But what happened was a couple of years ago, Microsoft bought a company called Revolution Analytics, which created essentially the equivalent of what SQL Server is to SQL. You submit a query and it scales on the data server. They'll use all the available memory and parallel processing and stuff. That's what SQL Server does, right? And that's what our server did that Revolution Analytics supported or sold. So Microsoft looked at this and said, we want to support machine learning better than we have. We really don't have support yet. So they reached out and bought that company. And Revolution Analytics is basically now part of Microsoft. And what you get as a customer is that scalable, powerful machine learning server is now free to you, or part of Enterprise Edition of SQL Server, and some support. I don't know exactly where it cuts off in other editions. It's great because you now have a single point where you can do all your machine learning if you want to use relational database. You're using SQL Server. 2017 added support for Python, so that was not originally part of it. It used to be called R Server. Now it's called Machine Learning Server because Python is also supported. And I don't have time, I wish I did, to get into a full demo, but I am going to do, I think, a presentation on that later. But you can actually compile R and Python code right in the database in store procedures. You can call it from SQL Agent. You can do everything right within the database. So there's some things here about how to scale things out and set up things within the parallel processing for these machine learning routines. Some more things just about it. So what it does do, and I think I do have a slide on this. Nope, it's not there. It's probably going to pop up in the wrong place again. But what it does is there's commercial functions that all start in the R version with Rx. And those are the scale functions that you replace your open source versions of the functions. So if you're doing like GLM, you would probably use something like RxLM for a linear model. And then it will scale, it will use all your memory, it will page in and out if needed, etc. So you do have to make adjustments, and that's a common pattern if you do it with Spark as well. Spark has MLlib, which is also designed to parallelize and scale out for machine learning. So to get that kind of support, you would need to, convert your model somewhat. But it's not difficult to do, and the sort of syntax you're used to all works. So it's really good, and there's a lot of really cool functionality in there. JSON support is also something that's really big now. Obviously, JSON has become the ubiquitous replacement, I think, to XML. So you've got built-in JSON support and t-sql extensions for that. And finally, there's a thing called Polybase. And what Polybase is, I've not used it a lot, which is odd because I do a lot with Hadoop and Spark and all that. But the idea behind Polybase is to give you a SQL connection to Hadoop or blob storage in Azure. And you can use SQL against it. And it's really an ideal situation for ingesting data, I think. I think a common use case would be you want to bring data in, and that's a nice, easy way to do it. And so these are different examples of where you can use it, querying data in Hadoop from SQL Server, particularly parallel data warehouse, querying data in Azure Blob Storage, importing data, exporting, integrating it with Power BI tools or BI tools. And finally, you've got things, these are things related to JSON, cross-apply operations, so I just want to make sure I don't leave anything out here, but computed columns, got new functions that you can use, new string functions, bulk import now supports CSV format, and Azure Blob Storage. So we've covered a lot, and I still haven't covered everything, so apologize if I missed things, and I know from a DBA standpoint I definitely missed things, and I would like to come back, as I mentioned in the beginning, and probably do a whole presentation just focused in on all the data architecture things, disaster recovery, always on, failover clustering, and all that great stuff. But I wanted to get really more into the features that I find, to be honest, more exciting, the things that allow business use and functionality and value of the data. And I typically have relied on DBAs to make sure it all works. So I hope you've enjoyed this, but again, I encourage you to look at SQL Server from that sort of service-based architecture. Makes it a lot easier to understand. And I guess the biggest takeaway you might want to take from this is SQL Server is not a single thing. It's really an entire ecosystem, and it does many different functions. In any other database, you would probably have to buy a lot of different tools to accomplish the same thing. My personal favorite thing about SQL Server is it is an awesome business intelligence and reporting platform, but it is also a great transactional production, really heavy-duty processing engine as well for those loads. So it's really a good one-stop shop for doing everything. And I hope you've enjoyed this presentation. Give me comments, share, like. I'm doing these things. I hope people like it. I wanted to do this because I've used SQL Server for a long time, and I haven't seen anything that just kind of talks about all the features without always doing it just one version at a time. So in this particular thing, I tried to capture not just the latest features in the 2017, but also a summary of all the features in general. Hope it's worked. Thank you, and see you later.